So in the last part we covered about bitwise operators. I hope you have clear idea about bitwise operators, right? So now the next terminology what we have to discuss keeps subheading short circuit operators. Short circuit operators. Short circuit operators. Short circuit operators within bracket double and double R. Short circuit operators double and double R. Double and double R. Short circuit operators double and double R. Okay. Now what is the difference between normal bitwise operator and a short circuit operator? Maybe a chance to ask, very rare, but there is a possibility to ask in an interview room. Sir, we have already single AND is there. Then what is the need of double AND? Are you getting? Already single AND is there. What is the need of double AND? Maybe a chance. Or what is the difference between these two? So if anyone is going to ask what is the difference between single AND and double AND, don't tell, sir, here we are taking single AND one time, but here we are taking two times. It is not the difference. What is the difference between these two? Compulsory you people should have clear clarity, right? Okay. Here just observe the point well. Sir, here suppose I have one if block is there. If here there is a big condition I am going to check. There is a big condition, big x greater than 10 and y, like if there is a big condition I am checking, and there is another condition is there b2, like, are you getting? If it is the true, execute this part, else execute this part. Like this is my requirement, right? Now observe. So to evaluate this part, B1 part, assume 10 minutes time is required. Assume 10 minutes time to evaluate this one. To evaluate this one, 10 minutes time is required. Then to evaluate AND operator, another 1 minute time is required. Total, how much time is required to evaluate? This argument, total how much time is required? 21 minutes time is required. After 21 minutes, if it is the true, execute this part, else execute this part. Is nothing but our requirement is right. If it is the true, execute this part, else execute this part. Now my question is, observe carefully, right? After first 10 minutes, we came to know that it is false. After first 10 minutes, we came to know it is the false. If it is the false, whether the second argument is true or false, the result is always false. If the result is always false, what is the need of evaluating second one? Because we know if the second one is the true or false, we don't know. It may be true or may return false. It may be false, but if the first argument is false, the result is always false, irrespective of whether the second argument true or false. That's why if I am using normal AND operator, whether the second argument evaluation is required or not required, compulsory it is going to execute. Unnecessary system time we are going to waste. Correct or not? Because after 10 minutes I came to know false, was total false. But if I use AND operator, compulsory another 10 minutes time it is going to spend to evaluate whether this one is nothing but total thing is a true or false. Are you getting? So that's why in the case of normal AND operator, whether the second argument is required or not required, compulsory is going to evaluate always. Okay, which may waste system time and creates performance problems, right? To overcome this problem, we should go for double AND operator, right? If I use double AND, so what is the difference? If the first one is the false, second one don't evaluate, just execute the else part, right? Because if it is required, then only second one is going to evaluate. If the first one is the true, then second one is going to evaluate. If the first one is the false, without evaluating second one, directly the control is coming to else part and else part is going to execute, right? So normal AND operator, short circuit AND operator, what is the difference is, in the case of normal AND operator, both arguments should be evaluated always, whether it is required or not required. But in the case of double AND operator, second argument evaluation is optional. If it is required, then only it will be evaluated. Can you tell performance wise which operator is good, single AND or double AND? Double AND is good. That's why short circuit operator is nothing but double AND. Relatively performance will be improved if I use a double AND operator, right? Are you able to understand what the difference between single AND double AND? Now the terminology is very clear for you people. Okay, this is suppose here observe, sir, I entered username and password. Username not matched. Sir, the specified username is not there in the database. Is it required to compare password? What is the use? Waste. Because username only not matched, then password not required to match. Is nothing but like in that particular case we should go for which operator? Is nothing but double AND, not a single AND operator, right? Are you able to understand what is the difference between normal bitwise operator, short circuit operators? Now the terminology is clear. Now just observe this one. So what the difference? Let me summarize. Normal bitwise operator and normal operators. Next short circuit operators, right? Short circuit operators. First point, just now I explained. First point, here both the arguments should be evaluated always. Correct or not? Both arguments should be evaluated always. But here second argument evaluation is optional. Second argument evaluation is optional. Sorry, if it is required, then only second one will be evaluated, right? Now second one, relatively performance is low or high? Low. Relatively performance is high. Okay, this is second. Third one, this one a bit important, right? Now make sure. Sir, if we consider double AND double R, just have a look once about this part, right? Here see X double AND Y. Sir, X double AND Y. Can you tell when Y will be evaluated, Anna? When Y will be evaluated? If and only if X is true, that is if X is false, Y won't be evaluated. So Y will be evaluated if and only if Y will be evaluated if and only if X is what? X is true. That is if X is false. That is if X is false, then Y won't be evaluated, right? If X is false, then Y won't be evaluated, right? Okay, this is same X double R Y. Sir, when Y will be evaluated? If X is false, then only Y will be evaluated. If and only if X is false. That is if X is true. That is if X is true, then Y won't be evaluated, right? Then Y won't be evaluated. Like now the terminology is clear for you. Sir, here observe, if X is true, then only Y will be evaluated. If X is false, then Y won't be evaluated. If X is true, then Y won't be evaluated. If X is false, then only Y will be evaluated. Clear indication these operators applicable only for Boolean type. Sir, first is true, second one is false, or first is false, second then only, like. So these operators always talks about only for Boolean types. Correct or not? So you can't apply these operators for integral types. But if we consider normal and normal operator, we can apply for normal and normal R. We can apply for Boolean type. We can apply for integral types. But these operators applicable only for Boolean, but not for integral types. Is it clear, right? Okay. Now applicable applicable for both boolean and integral types, applicable for both boolean and integral types, but applicable only for boolean but not for integral types, I hope you people aware. If anyone is going to ask the question, what is the difference between normal and normal R, double and double R, bitwise operator, short circuit operator, you should aware clear. Like in this case, both arguments should be evaluated always. In this case, second argument evaluation is optional. If it is required, then only second argument will be evaluated. Next, relatively performance is low, performance is high, applicable for both boolean and integral types, but applicable for both, applicable only for boolean but not for integral types. Clear for all of you? Yeah. Short circuit operators within bracket double and double R. I hope you took this one under the tab. These are exactly same as bitwise operators. These are exactly same as bitwise operators, exactly same as bitwise operators within bracket and R, and R, normal and normal R, and R except the following differences, except the following differences, okay. Take this pattern, take the table first, and then I will dictate the points anyway. Double and double R, I mean single and single R, double and double R. Take clearly this table. Anyway, I will dictate the points. Completed, right? Only table form. Okay, in that first point, that both arguments should be evaluated always. 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 Here, second argument evaluation is optional. 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 Next, second point, relatively performance is low. Relatively performance is low. Next, relatively performance is high. Relatively performance is low. Relatively performance is high. Next, third one, applicable for both boolean and integral types. Applicable for both boolean and integral types. Next, this one, applicable only for boolean. Applicable only for boolean. Only for boolean, but not for integral types. Applicable only for boolean but not for integral types. That's all. Completed, right? So this is what is the difference between normal bitwise operators and short circuit operators, right? Now add note, like take note in that first one, add this point, x double and y, add y will be evaluated if and only if x is true. If and only if x is true. That is if x is false, that is if x is false, then if x is false, then y won't be evaluated. That is if x is false, then y won't be evaluated. Y won't be evaluated. Y won't be evaluated. Next term, x double r y. X double r y. X double r y. Y will be evaluated. Y will be evaluated. Y will be evaluated. If and only if y will be evaluated, if and only if x is false. If and only if x is false, y will be evaluated. If and only if x is false, that is if x is true, that is if x is true, then if x is true, then y won't be evaluated. Y won't be evaluated. Okay. So these are differences between normal operator, normal bitwise operators and short circuit operators. But from this concept, what kind of questions we can expect for the exam? Here just two possible questions for the exam sake. Here listen this point well. Here I am taking, just observe. Sir, here int, just have a look once. Int x is equal to 10 I am taking. Int x is y is equal to 15 like I am taking. Int x is equal to 10, y is equal to 15. If plus x less than 10, plus x less than 10 and plus y greater than 15, plus y greater than 15, then x plus else y plus system dot out dot println x dot y like I am taking, x dot y like this I am taking, right? Can you tell, so what is the output I will get? Because here I use a normal and. If it is a normal and, both arguments should be evaluated or not? Yes. Now my question is, if I am taking normal and operator, what is the x, what is the y? Again, if I use a double and, what is the x and what is the y? If I use a normal r and a double r, what is the output by default we are going to get? This is my requirement, right? Now let me explain. Okay. Here just observe a bit carefully. X value, what is the x value? 10 plus x 11. 11 less than 10, false. If it is a false, normal and compulsory second one also should be evaluated. That's why plus y, what is the value? 16. 15 y value 15 plus y 16. 16 greater than 15. True or false? True. False and true. False. Else part. Y value will be incremented once again. Already y incremented. Once again y value is going to increment. So how many times x incremented? One time. But how many times y incremented? Two times. Here one time, here one time. That's why what is the x value? 11. What is the y value? 17. Make sure x value is nothing but 11, y value is what? 17. Okay, like next x is, if I don't want to use single and, I want to use double and. Now first one, true or false? First one, true or false? False. If it is a false, second one will be evaluated or not? No. Short circuit operator. If the first argument is the false, second argument won't be evaluated, because whether it is the true or false, the result is always false only. Directly the control is coming to this part. Then it is y value will be incremented. So how many times x is incremented? One time. How many times y incremented? One time. What is the answer we are going to get? X is 11, y is 16. Have you observed? Single and double and difference in the value. Are you getting? Okay, this. I don't want to use double and, I want to use R symbol. R symbol. Now, is it true or false? False. Whether it is the true or false, compulsory second argument will be evaluated. Normal or operator. True or false? True. False or true? True. This one, x value incremented. How many times x is incremented? 2 times. Here 1 time, here 1 time. How many times y incremented? Only 1 time. Or the answer, x is 12, y is 16. Now, sir, I want to take double R. Double R. X is it true or false? False. If it is a false, compulsory second one should be evaluated. In the case of even short circuit, second one, is it true or false? True. False, true, true. Then x value. Can you tell what is the value of x? What is the value? 12. What is the value of y? Only 1 time incremented. That's why 16. Because first argument is the false. That's why normal R, double R, there is no difference at all. Are you getting? There may be a chance to ask this type of questions for the exam. You should aware AND operator or double AND operator, R or double R. Take this example, right? Take clearly. Into x is equal to 10, y is equal to 15. Like, better to take output also. This is the short circuit operators what we have. Completed, right? So take clearly the output what we are going to get. So very important part for the exam, this type of things. Second possibility to ask, that part I will explain. Second possibility for the exam. This is the example 1. So we should have clear clarity. Next, the second one, concept is the same, but style is a different. Legend. Second example, also very easy to ask. Same example. I am taking int x is equal to, int x is equal to 10. I am taking, that's all. Int x is equal to 10. If plus x less than 10, plus x less than 10, double and x by 0 greater than 10. X by 0 greater than 10. System dot out dot println. Okay. Hello. Else system dot out dot println hi. Are you getting? Else hi. Like this I am taking. Hello, hi. Now can you tell what is the answer by default we are going to get? Here just observe. It is okay. So first option, compile time error. Second option, runtime exception, arithmetic exception, division by 0. Third option, hello. Fourth option, hi. Now, which one is the correct? Okay. So by overlook, most of the people do know, sir, 10 by 0, division by 0, arithmetic exception like, most of the people are going to fail. No, is an atima. Here just observe. Sir, is it true or false? False, because plus x 11 less than 10, false. If the first one is the false, second one won't be executed. You are not giving the chance to execute. False, directly the control is coming to which part? Else part. That's why the output by default we are going to get is nothing but high itself is the answer. Are you getting? Sometimes here observe, if I replace double and with a single and, if I replace a double and with a single and, then what will happen? Second one will be evaluated 10 by 0 arithmetic exception. So second one is the correct answer. Are you getting? Single and double and, there is a difference in the behavior, right? Okay, take this example. Take clearly example 2. That's all. These are various things you should aware related to short circuit operators. Runtime exception, arithmetic exception, division by 0, hello, highlight. Can I complete it right? Okay, get the point well. So high itself is the answer. Just I add one theory below this. If we replace double and, I mean this symbol, double and with a single and. If we replace a double and with a single and, double and with a single and, then we will get runtime exception saying, arithmetic exception division by 0. Runtime exception saying arithmetic exception division by 0. Division by 0. Arithmetic exception division by 0. That's all. Completed, right? There ends short circuit operators, right? These are the only possibilities we have related to short circuit operators. Now keep submitting. Typecast operator. Typecast operator. Okay, here very simple, it's also nothing. There are two types of typecasting we have. There are two types of typecasting. The first category, implicit typecasting. Okay, automatically what the second category? Wow, too good, Anna. What is the second one? Explicit typecasting. Okay, so the first one implicit, second one is what? Explicit typecasting, right? So what is implicit, what is explicit, we will discuss. First add, there are two types of typecasting. There are two types of typecasting. First one, implicit typecasting. Second, explicit typecasting. Explicit typecasting. Now keep submitting. Implicit typecasting. So just another 10 minutes, the power will come anyway. So now just observe, there are two types of typecasting, implicit typecasting and explicit typecasting, right? In that implicit typecasting, if you observe implicit typecasting, what it means? Here see, suppose I am taking int x is equal to a. Sir, listen, int x is equal to a. If I can take system.out.println of x, into x is equal to a, SOP of x. Can you tell what is the output we will get? Into x is equal to a, SOP of x. What is the output we will get now? 97 we will get. 97. But actually we provided char, but I am getting the output as 97. Someone converting my char to int type. Are you getting? Someone converting char to int type. Who is converting that? Is nothing but, who is converting that? Internally compiler is responsible. This type of conversion, this type of typecasting is nothing but implicit typecasting. Are you getting the point, right? Okay. Now observe this one. So internally compiler converts char to int automatically by implicit typecasting. Is nothing but, this type of conversion is by default considered as implicit typecasting. I hope you people aware. But actually I provided what? Char. But now I am getting what? 97 is nothing but like. Same here, observe this one. I am taking double d is equal to 10. Sir, double d is equal to 10. SOP of d I am taking. Double d is equal to 10. SOP of d I am taking. Now here observe. Double d is equal to 10. SOP of d. Sir, internally make sure here you should aware clearly, right? So internally double d is equal to 10 SOP of d. Int value will be converted to what type? Double type. If I print what is the value, I am going to get 10.0. Are you getting? 10.0 by default we are going to get. Okay, this is. So compiler converts into double automatically. Compiler converts into double automatically by implicit typecasting. Is nothing but like. Are you able to understand? So who is the responsible to perform implicit typecasting? Compiler is responsible. Are you getting? When implicit typecasting will be performed? Have you observed? Sir, char to int or int to double. When implicit typecasting will be performed? Whenever we are assigning smaller data type value to bigger data type variable. Sir, char is 2 bytes, but int is how many bytes? 4 bytes. Int is 4 bytes. Double is how many bytes? 8 bytes. So whenever we are assigning smaller data type value to bigger data type variable, then implicit typecasting will be performed. Are you getting? Now first conclusion. Who is the responsible to perform implicit typecasting? Compiler. Second one, here have you observed? When implicit typecasting will be performed? Smaller data type value to bigger data type variable. If we are assigning smaller to bigger is nothing but then implicit typecasting will be performed, right? Next, keeping small value in the big container. Do you know what is this concept? Is also known as widening. It is also known as widening. Keeping small value in the big container is nothing but what? Widening or upcasting. It is also known as widening or upcasting, right? Now fourth conclusion, make sure you should aware. Sir, at any point of time 10.0 we can able to convert to 10. 97 we can able to convert to the char. So in implicit typecasting there is no loss of information, right? If really loss of information is there, then the compiler won't perform this activity, right? Okay, they say there is no loss of information in this typecasting. There is no loss of information in this typecasting, right? Are you able to understand? Okay, they say. So Who is the responsible to perform implicit typecasting? Compiler. Next, when implicit typecasting is required, whenever we are assigning smaller data type value to bigger data type variable, implicit typecasting is required. Next, it is also known as widening or upcasting. Next, there is no loss of information in this typecasting, right? Okay, this is. Sir, can you tell any areas where implicit typecasting is required or will be performed? Very simple. Here, see this one. Here, byte, whenever byte to short, implicit typecasting or not? 1 byte to 2 byte, yes, implicit typecasting. Short to int, char to int, int to long, long to float, float to double. Do you know? These are various possible conversions where implicit typecasting will be performed. I hope is that clear for all of you that these are various possible conversions where implicit typecasting by default will be performed. Now that terminology is clear. So who is the responsible to perform implicit typecasting? What are various important points? Under some examples, right? First take point by point. Take implicit typecasting. Under that first point, compiler is responsible. Compiler is responsible. Compiler is responsible to perform implicit typecasting. Compiler is responsible to perform implicit typecasting. Compiler is responsible to perform implicit typecasting. To perform implicit typecasting. Next, second. Whenever we are assigning smaller data type value, to bigger data type variable, implicit typecasting will be performed. Whenever we are assigning smaller data type value to bigger data type variable, implicit typecasting will be performed. Implicit typecasting will be performed. Okay. Next, third one. It is also known as widening. It is also known as widening or upcasting. It is also known as widening or upcasting. Widening or upcasting. Widening or upcasting. Upcasting. Fourth one. There is no loss of information. There is no loss of information. There is no loss of information in this typecasting. There is no loss of information in this typecasting. There is no loss of information in this typecasting. In this typecasting. Okay, this is next point. The following are various possible conversions. The following are various possible conversions. The following are various possible conversions where implicit typecasting will be performed. The following are various possible conversions where implicit typecasting will be performed. Where implicit typecasting will be performed. Implicit typecasting will be performed. Okay. Take this diagram. Byte to short, short to int, byte to short to int, int to long, long to float, float to double, long to float, float to double, float to double, byte to short to int, into long, float to double, and a char to int. Have we completed, right? So do you know smaller type to bigger type? If anywhere small type to bigger type acceptable, internally compiler is responsible to perform this conversion, right? Okay. Now add example 1, example 2. Take this one, example 1 and example 2. Take this part. example 1 and example 2, like completed, right? Compiler converts char to int automatically. Compiler converts char to int automatically, by implicit typecasting. Next, compiler converts into to double automatically. Compiler converts into to double automatically by implicit typecasting. Into to double automatically by implicit typecasting. That's all. Completed, I hope. Compiler converts into to double automatically by implicit typecasting. Next, compiler converts char to int automatically by implicit typecasting. So the typecasting which is performed internally by compiler is nothing but what? Implicit typecasting, right? But here make sure we know in this typecasting nothing will be there to discuss other than this. That's all. These are the things which is going to be happen automatically internally. We are not responsible for this, but there is some typecasting where we require to perform explicitly by the programmer. Such a type of typecasting is explicit typecasting, right? Okay, now keep subheading explicit typecasting. Keep subheading explicit typecasting. Okay, explicit typecasting. Here see, observe this point well. Here I am taking int x is equal to 130. Analogy, int x is equal to 130. Now I am taking byte b is equal to, int x is equal to 130, byte b is equal to x, like this. I will ask compiler, can you please compile this code? Byte b is equal to x. Compiler, can you please compile this code? Like, immediately compiler will tell, Durga, I can't compile because x is how many bytes? 4 bytes. But byte is how many bytes? 1 byte. Sir, 4 byte value you are placing inside 1 byte place is nothing but 1 byte. There may be a chance of loss of information. Are you getting? There may be a chance of loss of information. That's why I don't want to I don't want to compile. Like, compiler immediately will raise compile time error saying possible loss of precision. There may be a chance possible loss of precision. Found int required is nothing but what? Byte. Compiler is telling very decently, there may be a chance of loss of information. I can't to compile, like compile time error you are getting. Then immediately I have to convey, compiler, if any loss of information there, I will take care. If any loss of information is there, I will take care. Not required to worry. Can you please accept this code to compile? Because I have 3+ years of experience. Within bracket, not fake. Okay, this is not fake. I can handle loss of information, no problem. Can you please yellow this? How you can specify this? Is nothing but byte b is equal to byte of x. Byte b is equal to byte of x. Then immediately compiler is going to feel, if the programmer is going to take care loss of information, why I have to worry? Like, happily the code compiles fine. Are you getting right? So the typecasting which is performed explicitly by the programmer, this type of typecasting is nothing but what? Explicit typecasting. When explicit typecasting is required, whenever we are assigning bigger data type value to smaller data type variable. Whenever we are assigning bigger data type value to smaller data type variable, explicit typecasting is required. Clear for all of you? 2 points. Now here, after some time, listen well. After some time, now I'm trying to print SOP of B. I'm trying to print SOP of B. So what output by default I'm going to get today? No, minus 126 is the value I'm going to get. Whenever we got minus 126, then the programmer, of course, we are going to get shock, because what value I assign? 130. Compiler told there may be a chance of loss of information, either plus 1 or minus 1, but here 130 became minus 126, then the programmer is going to get shock. But at this point of time, someone feels very happy. Who is that person? Compiler. Because compiler told at the beginning, Durga, not recommended to perform this assignment because there may be a chance of loss of information. Like, so I have 3 years of experience. Do you know, not fake. I can handle. Now the compiler felt very happy by seeing this result. Right? Are you getting? In explicit typecasting, there may be a chance of loss of information. Correct or not? Okay, this. So first point number 1. Listen, Anna. Who is the responsible to perform explicit typecasting? Programmer is responsible, right? Okay. Second, when explicit typecasting will be performed? Whenever we are assigning bigger data type value to smaller data type variable, explicit typecasting will be performed. Clear for all of you? That is nothing but second. So bigger data type value to smaller data type variable, explicit typecasting will be performed is the second. Next, the third point, okay, when, okay, is there any keeping big value in the small place? Is nothing but is it narrowing or widening? Narrowing or downcasting or upcasting? Downcasting, like. Next, there may be a chance of loss of information or not? Yes, there may be a chance of loss of information, because 130 suddenly it became what? Minus 126, right? I hope you people can aware, okay, at this point. Yeah, first point. Programmer is responsible. Programmer is responsible to perform. Programmer is responsible to perform explicit typecasting. Programmer is responsible to perform explicit typecasting. Next, second point. Second, whenever we are assigning bigger data type value, bigger data type value to smaller data type variable, whenever we are assigning bigger data type value to smaller data type variable, then explicit typecasting will be performed. Then explicit typecasting will be required, or explicit typecasting is required. Explicit typecasting is required. Next, third one. It is also known as narrowing. It is also known as narrowing or downcasting. It is also known as narrowing or downcasting. Next, fourth one. There may be a chance of loss of information. There may be a chance of loss of information in this typecasting. There may be a chance of loss of information in this typecasting. Okay. Now here, if you observe, here observe this one. Sir, what are various cases where explicit typecasting is required? Observe this one. Sir, I have byte is there, short is there, byte short, int long, again byte short int long, float double, and here char is also there, char. If you move from left to right, are you getting? If you move from left to right, implicit typecasting, smaller to bigger. If we move from right to left is nothing but what? Explicit typecasting, because bigger to smaller type. So double to float, float to long, long to int to short or short to byte, int to char. Are you getting? So if we move from left to right, if we move from left to right, what is this typecasting, Anna? Implicit typecasting. Implicit typecasting. If we move from right to left, if we move from right to left, what is this one? Explicit typecasting. Explicit typecasting. So now the terminology is clear. The following are various possibilities. The following are various possibilities where explicit typecasting will be, where explicit typecasting is required. Various possibilities where explicit typecasting is required. Explicit typecasting is required. Is required. Explicit typecasting is required. Okay. Take this diagram. Take this diagram under these things also. So I hope this one got completed. Now example 1. Listen. This point well. Here observe same thing. Just if we consider, let me go for a simple example I am taking. Class test. You are seeing int x is equal to 130, like I am taking. Int x is equal to 130 I am taking. Byte b is equal to, okay, x. Byte b is equal to x. SOP of so b, like this I am taking. Now observe. Can you tell is the code is a valid or not? Now, is it valid or invalid? Invalid, because how you can assign 4 byte int value to 1 byte variable, like compile time error we are going to get. Now let me take here, observe the point well. Let me take this one, java c test.java. Compile time error. Compiler is providing very decently was possible loss of precision. So found int but required is nothing but byte. Now I have to tell compiler, if any loss of information there, I can take care. Not required to worry. Can you please accept this code to compile? I want to spell out how we can byte. Are you getting? Byte b is equal to byte of x, like this I am taking. Now have a look once. Happily the code compiles fine. What is the output? By default we are going to get Java test. What is the output? Is nothing but minus 126. Sir, minus 126 what I took? It is not random value. Remember, it is exactly original value only. Is it clear for all of it? Okay. Take this example first. Take this example. Int x is equal to 130. Int x is equal to 130. And x is equal to 130, byte b is equal to x. So comparative matter we are going to get saying possible loss of precision found int required byte. Found int required byte. Next byte b is equal to byte of x. SOP of b. For the output by default we are going to get. What is that output we are getting? Can I spell out? What is the output we are getting? Minus minus 126 is nothing but like we are getting minus 126 like this we are getting, right? Okay, now the next terminology, okay, make sure you should aware clearly, right? What is the next important? You may ask, sir, 130 how it became minus 126? Do you want to know? Because in the exam they may not ask 130, then you may tell minus 126. They may ask 150. They may ask 150, then the answer is? Then the answer is? Minus? Minus 126 is the value for 130. If they are asking 150, then the answer is? Minus 108. Minus 108. No. Ante 150. If I am providing 150, then the answer will become what? Minus 108. Okay? How this loss of information is happening? Compulsory you should have clear clarity. Okay? Let me explain. 130 suddenly became minus 126. Minus 126. If it is the 150, how it will become minus 108? Minus 108. I will show anyway. Listen this one. Sir, here int x is equal to 130. I am taking 130. Byte b is equal to byte of x. Byte b is equal to byte of x. SOP of b. Like this I am taking, right? Sir, in explicit typecasting, what thing is happening? What internally what thing is happening? Like we should aware. Now observe this point well. Sir, 130 internally how we can represent 130? How you can represent? Because it is how many bytes are? 4 bytes. 32-bit value. Is it a positive number or negative number? Positive. That's why 0. Positive. That's why 0. If it is a positive, remaining bits represent value directly. That's why 130. Okay, now here I am taking 265 0. 230 1. 216 0. 280 240 220 210. Are you getting? Now int x is equal to 130 means 0 0 0 0 0 0 0. Okay, now what is the value? 1 0 0 0 0 0 1 0. Now 1 0 0 0 0 0. How many zeros are? 1 1 2 3 4 5 followed by 1 0 like. Are you getting the point? 1 0 0 0 1 0 by default we are getting is nothing but int x is equal to 130 like. Now byte b is equal to byte of x. Now byte b is equal to byte of x. Here whenever we are assigning bigger data type value to smaller data type variable by explicit typecasting, whenever we are assigning bigger data type value to smaller data type variable by explicit typecasting, the most significant bits will be gone. Here how many bits are? 32 bits. But byte is how many bits? Byte is how many bits? Just 8 bits. Then how is so here which 8 bits will be considered? Only last 8 bits will be considered. The most significant bits by default will be gone. That's why what will happen is 1 2 3 4 5 6 7 8 is nothing but 1 0 0 0 0 0 1 0, right? And a very important bit. So whenever we are assigning higher data type value to lower data type variable by explicit typecasting, the most significant bits by default will be gone. Is nothing but we have to consider only last bits, last 8 bits only, right? In this, what is the most significant bit here? 1. 1 means what? Negative number. If it is a negative number, the remaining bits will represent a value in 2's complement form. We covered already. The remaining bits will represent value in 2's complement form. Correct or not? Now let me find out 2's complement form for this. What is the first 1's complement? 1 1 1 1 1 0 1. Add 1, add 1, 1 plus 1 0, 0 plus 1 1, 1 1 1 1 1, like this. Are you getting? Now observe, 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6. Is nothing but like, so like we are getting. Now 0, 1 into 2 power 6. What about its value? 64, 32, 16, 8, 4, 2, 0. 4 to 0. Can you please add Anna? 64 plus 32. Here last one. 0 into 2 power 0 means 1. 0 into 1 will become 0 only. Okay, this is. So 64 plus 32, 96. 96, like if you count this, what is the answer? Have you observed? Legend. 64 plus 16. Assume 80. 80. 64 plus 80. 32 plus 8, 40. 40 plus 80, 120. 124, 126. Now 126 itself is the value. 126 is the value. Like, are you able to understand that? Whenever we are assigning bigger data type to smaller data type variable, the most significant bits by default will be gone. We have to consider only LSB bits, right? Okay, this is clear. Now, what the answer? Minus 126 itself is the answer by default we are going to get. Is it clear for all of you? Right? Internally, in typecasting, what thing is happening is nothing but like you should aware at this point. Yeah, now. Whenever we are assigning bigger data type value to smaller data type variable, whenever we are assigning bigger data type value to smaller data type variable by explicit typecasting, the most significant bits will be lost. The most significant bits will be lost. We have to consider only LSB, least significant bits. We have to consider only least significant bits. We have to consider only least significant bits like. Is it clear for all of you? Right? Okay, this make sure take this internal analysis. Take this part clearly, right? Take this total thing. Completed, right? So next one, example 2. Just observe. Example 2. Here legend, this example same. Once again, one more example to get much clarity. Here observe. Byte, take special care about this example, right? Here I am taking int x is equal to 150. Sir, now 150 value I am taking. Short s is equal to short of x. Short s is equal to short of x. Sir, can you tell what is the x value? 150. 150 within the range of short or not? Yes, that's why there should not be a problem at all. SOP of yes. Are you getting? Maybe a chance we will get 150 because 150 valued short value only. Now byte b is equal to byte of x. system dot out dot println of B I'm taking. That's all. Only two examples, right? Here see. So 150 into value. I'm trying to typecast to the short type, and I'm trying to typecast to the byte type. Now we have to tell what is the output by default we are going to get. Okay, very simple terminology. Nothing. Here see. Here I'm taking, just observe this point well. Here int x is equal to 150. How you can represent in the memory? Sir, can you tell what is the most significant bit? 0. Because it's a positive number, 0. Now 150. Let me convert to binary. Can you tell what is that? 275 0. 2 what's the next one? 37 1. 218 0. 218 0. Sorry, 218 1. 29 0. 241 22 0 210. Are you getting? 2 is nothing but 1 0. Now so 1 0 0 1 0 1 1 0. So 0 0 0 dot 0 0 0 dot. Now 1 0 0 1 0 0 1 0 0 1 0 1 1 0. That's all. This is the value of 150. 150 value is nothing but like we have. Now my next target is observe. Sir, let me typecast to short type. Short S is equal to short of X. Short S is equal to short of X is nothing but like I am taking, right? Now observe, in the what is the most here I am trying to typecast to short. Short means how many bits? How many bits? 16. Now from the last 16 bits we require to consider. That's why 1 2 3 4 5 6 7 8 9 and so on 16. Now what is the value now? 0 0 0 0 1 0 0 1 0 1 1 0. Is nothing but like. Now SOP of S. Sir, what is the value? Simple. What is the most significant bit? 0. 0 means positive. If it is a positive, remaining bits represent value directly. What is the value represented by this one? Sir, what is the value represented by? 1 0 0 1 0 1 1 0 1 0 0 1 0 1 1 0 150. That's why the value 150 directly. So what output we are going to get? 150, right? No doubt at all, because 150 is the value, short value. That's why there is no loss of information in this case. Is it clear, right? Okay, this way. But now byte B is equal to byte of X. Byte B is equal to byte of X. Like this sum I'm taking, right? Byte B is equal to byte of X. Sir, byte means how many bits? Byte means how many bits? 8 bits. 8 bits. Now so for the last 8, 1 2 3 4 5 6 7 8. Have you observed? 1 0 0 1 0 1 1 0. Again, in that what is the most significant bit? 1. 1 means what? Positive or negative? Negative. If it is a negative, remaining bits represent value in 2's complement form. You know what the 2's complement form? 1 1 0 1 0 0 1. Add 1 for this. 1 plus 1 0 0 plus 1 1 0 1 0 1 1, like we have. Okay. Now listen. 2 power 0 2 power 1 2 square 2 cube 2 power 4 2 power 5 2 power 6. Correct or not? 2 power 6. Can you tell what the value of 2 power 6? 64 plus 32 plus 0 into 16 0. 0 into 16 0. 1 into 2 power 3 8. 0 into 4 0. 1 into 2 plus 0 into 0. What about its value? 32 plus 8 40. 40 plus 64 40 plus 64 106. Correct, right? 104 plus 2 is nothing but what? Minus 106. No. Can you please cross check once again? 10 minus 106. Yes. Correct, right? Am I doing anywhere mistake? No. Let me cross check. So SOP of B. What is the value now? Minus 106 like. Okay, let me cross check. So here 1 minute. Just observe. By B is equal to here 150. Next short S is equal to short of X value. Next system dot out dot println. System dot out dot println SOP of S. Okay, this is. So observe what output by default you are going to get. Minus yes 150 and a minus 106. Is it clear for all of you? Right? Okay, this is what you people should aware at this example also. At the example, first take this part and then that memory representation. Just another only one more example and then we will stop this typecasting. Take clearly. Completed, I hope. Next, one more example. Is it clear, right? Next one. Completed? Next example. Example 3. So from here also you will get some clarity. Some here, listen this point well. Observe, I am taking double D is equal to 130.456. Double D is equal to 130.456. Now int x is equal to int of D. Int x is equal to int of D. System dot out dot println of x. Int x is equal to int of D, SOP of x. Next, byte B is equal to byte of D. Byte B is equal to byte of D. System dot out dot println of B. Byte B is equal to byte of D, SOP of P. Now take special care. Sir, here D 130.456. Whenever we are assigning floating point values to integral type by explicit typecasting, okay, then the digits after the decimal point will be gone. Are you getting? So SOP of X. What is the answer we are going to get? Digits after the decimal point will be gone. What is the answer? 130 by default. 130 by default we are going to get. Similarly, sir, here also 0.456 will be gone. 130 will be there. But 130 you can't place inside byte. That's why once again typecasting. Now what is the answer? Minus 126. Clear for you, right? Okay, this is simple conclusion. If we assign floating point data type values to the integral types by explicit typecasting, the digits after the decimal point by default will be gone. Okay, add the point. If we assign floating point values, to the integral types, if we assign floating point values to the integral types by explicit typecasting, if we assign floating point values to the integral types by explicit typecasting, the digits after the decimal point will be gone. The digits after the decimal point will be lost. The digits after the decimal point will be lost. will be last, okay. That's all. Take this example. Double D is equal to 130.456, double D 130.456 int x is equal to int of D, int x is equal to int of D SOP of x, int x is equal to int of D SOP of x. So the answer is 130. Next, byte B is equal to byte of D SOP of B. The answer is minus 126, minus 126, like, clear, right? 130 minus 126, like, that's all. So this is about typecast operator what we have. How many types of typecasting? 2, implicit and explicit. Implicit typecasting will be performed internally, but explicit typecasting will be performed explicitly by the programmer, right? Okay, that's all. Now the remaining I will continue anywhere.